last two things I want to cover are some properties that begin about triangles and parallelograms. I'm not going to cover them all, but just some things that I feel strongly are likely to see somewhere on the praxis test. And I want to make sure we review them and cover them so that you will be prepared. Remember, performance is a function of preparation. The last thing I want to have happen is a student fail the practice exam and say to me, if you would have just taken a few minutes to cover this or that, I would have passed. So I'm not going to let that happen. All right. So the first thing you want to know about a triangle is that the sum of the angles in a triangle, the three angles of a triangle, always add up to 180 degrees. That's what it says right here. So find the missing angle. Go ahead. So 82 plus 55 are going to add up to 137. And then if I subtract that 137 from the 180, that's the whole value of the triangle, I get 43 degrees. Let's do another like that. We're going to do the one on the right here first. Not the left, the right. Go ahead. So 82 and 27 adds up to 109, and then 109 minus 180 minus the 109 is 71. So those are real simple, real direct, straightforward. Three angles of a triangle add up to 180. If you're missing one of the angles, just add the two up that you have, subtract from 180, and bam, you've got your answer. But most of the time, they'll add some algebra to it, like those equations we worked on earlier in the year. So this time you have to write an equation that the x plus the x plus 2 plus the 38 add up to 180. Go ahead, do that. Okay, so the x plus the x plus 2, I really should have put in parentheses around it just so that you could have seen and isolated that, so it made a little more, it stood out to you. But x is this angle at the top, x plus 2 is the angle on the right, and 38 is the angle on the left. So it's really just the first angle, x, plus the second angle, x plus 2, plus the third angle, 38. They're all going to add up to 180 degrees. So simplify, same side, same operation. That's 2x's and 40. So 2x plus 40 is 180. Subtracting the 40, I get 2x's 140 dividing by 2, and I get x is 70. Okay. So remember, three angles of a triangle always add up to 180 degrees. Okay? As we just did, we can throw algebra in this, or we can do things sometimes arithmetically. But there's another type of triangle that is an important type. There's an equilateral triangle, which everybody pretty much remembers that equilateral triangle, equilateral, equal sides. That's what lateral means, like you lateral a football sideways, or your lateral collateral ligament is on the side of your knee. So an isosceles triangle has two equal sides. That's what these markings mean here. And anytime you have two equal sides, you also have the base angles equal. And those are the sides that are across, the angles that are across from the two sides. This 116 up top is often called a vertex angle. So the vertex angle is the one by itself. The two base angles of an isosceles triangle are across from the congruent or equal sides, and those base angles are always equal. So given that those base angles are equal, and given that the vertex angle is 116, find the value of B. Okay, so 180 minus 116 brings me to 64, but the two base angles are equal, so I do 64 divided by 2, and I get 32. Try this one. That 100 is the vertex angle, and you know by these gray marks on each of the legs over here that that is an isosceles triangle, and the sides are congruent. So again, find x. Now, I know you can write out a fancy formula here that x plus x is equal to 100. X plus x plus 100 is equal to 180, subtracting 100 from both sides and so on. But I find most students who can just do this arithmetically. First off, the base angles are equal, so this is x. So if I subtract the 100 from 180, I get 80, and the two base angles are equal, so 80 divided by 2 is 40. So this relationship where the base angles are equal, this can be used in a couple of different ways. The way I just did before, but we can also do it where we start with the base angles and go back and find the vertex angle, the one that's not equal. Go ahead. Okay, so 47 times 2, because there's a 47 and a 47 congruent base angles, is 94. And 180 minus 94 is equal to 86. That's the vertex angle up top. These are the base angles at the bottom. Okay. So it asks us to find x here, and for some reason this wasn't animated, but the x has to be 40 degrees. The emphasis here is that these markings in blue, they show that those are the two legs of an isosceles triangle, which means that the legs are equal. So the angles across from those legs, the base angles, are going to be equal as well. Okay? Now, look, sometimes they try to mess you up a little bit, and what they'll do is they'll flip the triangle upside down, or they'll spin it left, or they'll spin it right. What you need to learn to do is to look for markings in your diagram, like these hoops down here that say that these two angles are equal because the hoops are marked the same way, or for the sides to be marked and you look for the angles across from them. Try this one. Okay, so since these angles are marked to be congruent, and that means they will be equal, so 4x plus 12 will equal 5x minus 3. And this is an opposite side, opposite operation situation, so I subtract 4x's, always starting with the smallest x's from both sides, and I get 12 equals x minus 3. Adding 3 to both sides, x is equal to 15. Okay? And we can do an even similar idea with the fact that we'll use algebra. But now remember, these three angles add up to 180 degrees. Can I ask for an expression that's equal to angle G? Well, remember, based on the markings, angles B and G are the same. So a marking for angle G would be x plus 10. So go ahead, add up those three angles and get 180 degrees. Okay, so the 3x up top plus, and this is where I did put the angles in parentheses just to isolate them, the x plus 10 on the left plus the x plus 10 on the right is going to equal 180. So combining like terms, that is same side, same operation. 3x and another x make 5x, 10 and 10 make 20. So subtracting 20 from both sides, and I get 5x is 160. Dividing by 5, and I get x is 32. Okay, so there are some basic problems that involve triangles, isosceles triangles, and finding angle measures of the triangle. Now, parallelograms. The properties of a parallelogram that we want you to remember are that the opposite angles of a parallelogram are congruent. By opposite angles, we mean the ones that are across from each other. For example, this angle B and angle D, or angle A and angle C. Those are opposite angles. And consecutive angles are going to be supplementary. Supplementary meaning adds up to 180 degrees. So B and C are going to be supplementary. B and A are going to be supplementary. But B and D are going to be congruent because B and D are opposite or across from each other. Consecutive means they're next to each other. So find the measures of angle Y first, because that's the first one I'll show you, and then X and then Z. Go ahead. Okay, so again, opposite angles are congruent, so angle Y will also be 100. And consecutive angles, the angles that are next to each other, they have to add up to 180. So that's 80. And then either because A and B are next to each other, A has to be 80 or Z, or it's directly across from angle X or C, so that also has to be 80. All right, let's work on the first figure here, number 1. Let's find X, Y, and Z. Go ahead. Okay, so remember, opposite angles are congruent, so the first one I'll fill in will be Y. That's 115 degrees because it's opposite or across from it. Consecutive angles are going to be supplementary. So X is next to or consecutive with the 115. So X is 85. And Z is across from the X, which would be 85. All right. So you try number 2. Again, opposite angles are congruent, so angle X will also have to be 50, and angle Y is going to be supplementary. Remember, supplementary means adds up to 180. So 50 and 130 add up to 180. And Z is either opposite Y, making it 130, or supplementary to 50, making it 130. Either way, it works. That is one of the great things I feel about mathematics. If you go in a history class and one student or half the class is liberal and the other half of the class is conservative, you hardly ever come to agreement on anything. But if you are in mathematics, whether you want to look at it from a supplementary point of view or a congruent point of view, you will arrive at the same solution. And I personally find that comforting because I don't like to fight all day long. And Lord knows some of those people in social studies class just do not understand some things that other people think they do, and vice versa, and so on. Okay, number 3, go ahead. Okay, because X is opposite the 121, X has to be 121. And Y is supplementary to the 121, which means it is 59 degrees. And Z is opposite Y, so it's also 59, or supplementary to 121, any way you want to look at it. Now, these are all just quick arithmetic operations and calculations. Sometimes we have to do a little bit of algebra with the same exact concepts. So let's do the one on the left first. Okay, so what we have here is that they're opposite angles. Once you establish the relationship, then you write the equation. They're opposite each other, which means they have to be equal. So X plus 29 is 87. Subtracting 29 from both sides, X is 58. When I look at number 2, however, the relationship's a little different. Go ahead. So in number 2, they're consecutive angles, which means they add up to 180. So X plus 2X has to add up to 180. Combine like terms, same side, same operation. 1X and 2X add up to 3X, dividing by 3, and X is equal to 60. So those are the relationships in a parallelogram. And by the way, a parallelogram is called a parallelogram because both pairs of opposite sides are congruent. I teach a geometry course for the school, and it's pretty cool. You know, there's a couple of things in it that are a little tough, but we spend a lot of time going over these relationships and more. But it's understandable in the sense that it really does increase your ability to think and process all these mathematical terms. And it's not a particularly hard course. Teaching it now, the students are doing really well. They're getting some very, very, very good grades in it. Okay. Next up, not only did we talk about the sides, but we also need to talk about, we talked about the angles. We now need to talk about the sides. The opposite sides of a parallelogram, both pairs, are going to be equal to each other. So this line at the top, called AB, that's going to equal CD. And AD on the left is going to equal BC on the right. But in this case, we only have top and bottom, so they're equal to each other. So because we know they're going to be equal, I can write the equation 5x minus 8 equals 2x plus 13, and then we can solve. Go ahead. Okay, so 5x minus 8 equals 2x plus 13. Opposite side, opposite operation situation. Subtracting the 2x's, and I get 3x minus 8 is 13. Adding 8 to both sides. 3x is 21. Dividing by 3, and x is 7. Here's one for you to try, but in this case, first I think, because I think it's easier to get y. So the opposites on the left and the right are going to be congruent. By the way, if you see these little arrow symbols, the one arrow to the one arrow means those two sides are parallel to each other, and then the two arrow to the two arrow means that those two sides are parallel to each other. And as we've already learned, opposite sides of a parallelogram, which this is, are congruent. So therefore, the y plus 3 must equal the 12. Go ahead, solve that one. So y plus 3 equals 12. Subtract 3 from both sides. Y is 9. Now, it's also true of the top and the bottom. So 6x minus 7 has to equal 2x plus 9. Go ahead. Okay, so 6x minus 7 will equal 2x plus 9. Subtracting 2x from both sides, and I get 4x minus 7 is 9. Just remember, I always like to start these opposite side problems by eliminating the smallest variable. Now add 7 to both sides. 4x is 16. Dividing by 4, x is 4. Okay, so that's what we need to know about the opposite sides of a parallelogram, that they are parallel and that they are congruent. The last thing I want to talk about is the diagonals of a parallelogram bisect each other. And the reason I want to talk about these is, first off, you could see a question about this. And second off, you could see just a question about the term bisect. And I want you to understand both of those. Now, bisect means, bi means two, sect means cut. So bisect means cut into two, and it's equal parts. So if you look at this diagram on the left here, from D to O, see one hash mark is going to be congruent from O to B. That's one hash mark. The number of hash marks say that they are congruent. So these diagonals bisect each other and they are congruent to each other, okay? And then here AO will be congruent to CO, okay? Because again, the two hash marks say they are congruent. And that's always the case with a parallelogram, that the diagonals will bisect each other. So looking at this next figure right here, because the top of this line is 5, this top side here, the bottom side also has to be 5. And because the diagonals bisect each other, if QK is 3, then SK is going to be 3. So first, top and bottom are congruent, so we get 5. And the diagonals bisect each other, so we get 3. Now, the diagonals of a parallelogram bisect each other. So that means that this piece here with the y's, 6y plus 1, well, that's going to equal 4y plus 9. And the piece with the x's, 2x minus 5, well, that's going to equal x plus 7. I began with the y's, so why don't you begin with the y's? Also, find the value of y. We'll do that one, then we'll go find the value of x. So stop and start, find the value of y. Okay, so again, diagonals bisect each other, which means they cut each other in half. So the 6y plus 1 will equal 4y plus 9. Subtract 4y from both sides. 2y plus 1 equals, oh, I changed it to minus 1. Uh-oh. There's going to be a mistake made in my calculations here, and I don't want to go back and redo the whole thing. So can you just please go on your paper right now and change this to a minus 1 with the 6y? Make it a minus 1 so it matches mine. Okay, so add 1 to both sides, and I get 2y is 10, divide by 2, and I get y is 5. If you kept that as a plus 1 and didn't want to change it, which I really wouldn't blame you for, I really shouldn't have asked that, then it would work out to be y is 4. So either way, as long as you understand, they're equal to each other and you solve. And last but not least, and it wouldn't be anything if I didn't at least make one more sloppy mistake in the last lesson. I just have to do it because that's me. Always make sloppy mistakes. 2x minus 5 will equal x plus 7. Solve that out. Okay, subtract x from both sides. X minus 5 is 7. Yay, I kept the sign the same. Right? Good for me. Add 5 to both sides. X is equal to 12. That's my dog dreaming in the background. X is equal to 12. All right, so let's summarize what we went over today. First off, the three angles of a triangle add up to 180 degrees, or as Count von Count would say, 180 degrees. There she goes again. Isosceles, two sides are equal and the two base angles are equal. Vertex angle is the non-base angle up at the top. The opposite sides of a parallelogram are equal. The opposite angles of a parallelogram are equal. The consecutive angles of a parallelogram are supplementary, which means they add up to 180 degrees. And the diagonals of a parallelogram bisect each other. So I would love, absolutely love to get more in depth with the geometry and teach so much more of it to you. Unfortunately, it's beyond the scope of the class. So if you wanted to take a geometry class that gets into all of this material, you can do that next semester and so on and so forth. It's one of my favorite classes to teach. Actually, I don't think it's offered in the fall semester. I think it's offered only in the spring semester. So there you have your basics and your fundamentals clearly understood. We have now covered the last of the new material that we had to cover for this particular course. After this, I'm going to give you a pre-test for today, and I understand today was loaded with material, but I want to get 2 full practice days in before the final exam because some of you will need it to maximize your grade, and I don't want to cram things together. So we have this work, and then I'm going to add a pre-test, which you'll get some time to cover. It doesn't have to be today. And then we will finish up with a test later this week.